Hello students, today we are going to study concept of spreading coefficient. So there are four learning outcomes of this topic. Understand this concept of spreading coefficient. Then how the cohesive forces and adhesive forces they are correlated with the concept of spreading coefficient. How to improve the spreading coefficient, and lastly the applications of spreading coefficient. So when a drop of oleic acid is placed on the surface of the water, the drop of oleic acid it will get sprayed if the force of adhesion between the molecules of water and oleic acid is greater than the force of cohesion between the water molecules themselves and oleic acid molecules themselves. So this is related basically to the polarity and non-polarity of the molecules. Oleic acid it consists of 18 carbon atoms, so that makes it highly non-polar molecule, whereas water is highly polar molecule. So when this oleic acid it has to be sprayed onto the surface of the water, as you can see on this in this figure. So force of adhesion between the oleic acid molecules and the water molecules it has to be higher as compared to the force of cohesion which is existing between the like molecules of the oleic acid and the water molecules. So in order to study this concept in a better way, first we need to understand about how the forces of cohesion and adhesion works in the spreading coefficient. So for that purpose, we need to consider a simple experiment. Consider a hypothetical cylinder which is constituting of the two liquids. First is a sublayer liquid S and another is a spreading liquid L. Now, if I had to separate these two liquids, I will have to do some amount of work, and that work done it is represented in the form of the energy. So the energy which is required to break the unlike molecules, that is nothing but the unlike molecules of the spreading liquid and the sublayer liquid, that work done it is called as work of adhesion. So basically a surface or interfacial work, whenever the work is done, it is representing the surface tension which is multiplied by the area of the increment which is shown in the equation. Okay. Now when the work is done to separate these two liquids away from each other, okay, two new surfaces they are created, but the surface area is not being changed. So therefore there is an unit area change only, whereas there will be generation of the two interfacial tensions value or the two surface tension values. So that is nothing but on this in this part of the cylinder it will be gamma L, and in this part of the cylinder it will be gamma S. So the work done here it will correspond to gamma into unit area change. Accordingly, now this work done is equal to the newly created surface tensions, that is nothing but gamma L and gamma S, minus the interfacial tension which was destroyed when the cylinder was broken into two halves. Okay, so the total work of adhesion it will be represented by the symbol WA, that will be equal to the addition of the creation of these two new surfaces, that is nothing but addition of surface tension of these two new surfaces, gamma L plus gamma S, minus the interfacial tension which was destroyed in this complete process, that is minus gamma LS. So this is the final equation for work of adhesion. Then similarly we can think an experiment for studying the work of cohesion. Now consider again a hypothetical cylinder of a cross-sectional area 1 cm square consisting of only a spreading liquid L. Now here no sublayer of liquid S is present. So hence only one liquid is present. So no existence of interfacial tension. So when this cylinder is broken into two halves, it will result in the formation of again two new surfaces with the corresponding their interfacial tension and also with no change in the area increment. So here this part of the cylinder it will constitute a surface tension corresponding to gamma L, and again this part of the cylinder it will constitute a surface tension corresponding to gamma L. Initially, in case of an work of adhesion, here the surface tension which was created it was represented by the value of gamma S, but here in case In this case, when no sublayer of the liquid is present, the two new surface tensions which are created, they are represented by the symbol gamma L. So the total work of cohesion in this case, it is represented by WC, that is equals to twice of gamma L. So when we are saying two different liquids that are present in the cylinder, okay, the value of force of adhesion, basically it should be higher than the value of the force of cohesion. So this spreading coefficient, it is represented by the symbol S, and it is defined as, or it can be calculated from the equation WA minus WC, that is equals to, if you substitute the values of WA and WC in this equation, gamma L plus gamma S minus gamma LS, and minus work of cohesion, that is twice of gamma L, where gamma S, it is representing the surface tension of the sublayer liquid in this equation, then gamma L, it is representing the surface tension of the spreading liquid. This is the gamma L, surface tension of the spreading liquid, and lastly the gamma LS, that is representing the interfacial tension between the two liquids. Now we can rearrange this equation also, that is S is equals to gamma S minus gamma L minus gamma LS. Now this rearrangement is very simple, just we have to multiply this bracket by this value. Okay, there is another modification we can do for this equation, that is gamma S. S is equals to gamma S minus gamma L plus gamma LS. Now let us see this adjoining figure here, which has been shown in the presentation. Now there is a liquid substrate, okay, there is an air here which is present, and there is a surface, there is a droplet of the oleic acid which has to be present, or which has to be sprayed on the surface of the liquid surface or liquid substrate. So from this figure, it can be clearly understood that the spreading can occur when the value of gamma S is greater than the value of gamma L plus gamma S. Then and then only the spreading can occur. So in that case, we can say that the value of gamma S, it is positive, or the spreading coefficient of value is positive, and when the value of this gamma S, it is less than the value of sum of the two surface tensions, that is nothing but the gamma L and gamma LS, in that case the surface spreading coefficient value is negative, indicating no spreading. Now this spreading, it can be also thought in terms of the surface free energy. So initially we had seen the equation W is equals to gamma into delta A. So in that terms, we can say that the added substance will spread if it reduces the surface free energy of the system. We can say it another way also, if the surface free energy of the system of the new surfaces and the new interface, if it is less than the free energy of the old surfaces, then and then spreading will occur. Now this S and L, they are considered to be the pure substances. Okay. Now in reality, after some lapse of the time, each phase, it gets saturated with another phase, such as oleic acid getting saturated with the water and vice versa. So this means that although the initial spreading of the material may occur on the liquid substrate, it can be followed by the coalescence of the material into a lens, and the value of S, it becomes negative. So as a result, the initial spreading coefficient, if the value is positive, even after that some period of the time, the value of the spreading coefficient, it goes into negative. That is nothing but after saturation with the two phases. So this spreading coefficient value, it can be increased by the presence of polar functional groups in the structure, or reducing the non-polar chain length of the substance. So these are the basic two ways through which we can increase or the spreading coefficient value to our favor. So students, what do you think? What are the possible applications of spreading coefficient in the pharmacy? Please think over it. Okay, now we will move on to the possible applications of the spreading coefficient in pharmacy. So the first application is absorption of the medicaments. As you know that skin layer, it consists of polar and non-polar both uh, functional groups. Okay, the dermis layer, it is polar in nature, whereas epidermis layer, it is non-polar in nature. So when the cream or the lotion which is applied on the skin, it has to be sprayed on that affected area. Okay, initially it has to be get sprayed over the surface of the skin. So let us consider the spreading value of that particular cream or the lotion, spreading coefficient of that cream or a lotion, it is less, so spreading will not occur. So normally, if you have to improve the spreading coefficient value, we need to add another substance, that is nothing but called as surfactant. Now this surfactant substance, it will increase the polarity in the non-polar molecules, and in that way we can improve the spreading coefficient value. That was the first application. Then the second application, stabilization of the emulsions. Normally, emulsion is a system which is constituting of the two different phases, basically an oil phase and water phase. But this oil phase is to be uniformly distributed throughout the water phase. Now, as we can see, oil is non-polar in nature, whereas water is polar in nature. So the mixing is not possible. So in that case, again, the spreading of the oil, it can be occurred by the addition of a substance called as surfactant. Now the surfactant, it will induce the polarity in the non-polar oil molecules, and it will help to spread the oil droplets throughout the continuous water phase, and it will help to improve the stabilization of the emulsions. So as we can see in this picture, initially the oil phase and the water phase, they are immiscible with each other, but after the addition of the surfactant, there is a formation of a proper emulsion. Okay. Now normally a blend of surfactants that is used in the preparation of the emulsion. A single surfactant value, it does not suffice the HLB value which is required for the stabilization of the emulsion. So to overcome that, we use the blend of surfactants. So I hope all the students, you must have understood the concept of spreading coefficient and this application. Thank you.